Question 48. We've got a few forces here. They're all acting on this mass. And the important thing is, it says it lies at rest. So if it lies at rest, then when you add all these forces up, you're going to get an answer of 0. Or 0, 0, in fact. So looking at that and sort of arranging them into a simultaneous equation, on the top I've got a plus b minus 7 equals 0, or a plus b equals 7. And the second one, I've got b minus 2a plus 8 equals 0, so that equals minus 8. And if I subtract those two equations, I can figure out that 3a is 15, which gives me a is 5. I'll now go back to that one there. If a is 5, then b is 2. So part A is 5 and b is 2. But now this force is being removed, and it will start actually moving now then, won't it? So for part B, we've got AB, we've discovered what that is already, that was 5 and 2. And here I've got 2 and now minus 10. And so the resultant force of these is 7 and what's that? That's minus 8, isn't it? But it asks us to find out what the magnitude is. And the magnitude, of course, is the size of that. So we've got minus 7 squared plus minus 8 squared square rooted. So the magnitude is the square root of 113. Calculate to the nearest degree the angle between the line of action of r and the unit vector of I. What that means is, what angle does this thing here make? So that's 7 along and 8 down. What angle does that make with the direction of I, which is this direction here? So we're looking for this value here. So we're looking for a little bit of inverse trig here. So we've got the inverse tan opposite over adjacent, the inverse tan of 8/7. The inverse tan of 8/7, it says, to the nearest, I've got 48.8, so to the nearest degree, I've got 49 degrees for that there. Find the distance travelled by the particle in the first 3 seconds. So continuing the question a little bit further, do you remember we had the mass there? The mass was 0.8. So get some more space. So first thing I'm going to write is I'm going to use the force equals mass times acceleration formula. And the force we figured out a minute ago was the square root of 113. The mass was given in the question was 0.8, and that helps me find out what the acceleration is. So tapping that into my calculator, I'm getting 13.28 for the acceleration. I'll try to find out how far it goes, but it says it started at rest, so I'm going to have a u equals 0. I don't care what v is going to be. S is what I'm trying to find out. A, I've got 13.28. And it said what happens in, what did it say? Did it say 3 seconds? Sorry, I just forgot. First 3 seconds, so I've got t equals 3. And so I'm going to use an s equals ut plus half at squared there. Throw in these numbers. If I tap that in, I've got 59.78, also 59.8 meters.